Alright guys, so welcome back, and this one is going to be a video right before y'all's unit test and whatnot, covering vertex form and various transformations. We talked about this in class. I said I'd do a quick video about it outside of class. If you guys have questions, feel free to email me. Alright, so let's start with just what vertex form is. That's that f of x or y is equal to a x minus h squared plus k. In the description below, what I'm actually going to do is link a video that one of our students brought up. Another guy talked about how to change standard form into vertex form. Just in case my way was confusing, I'm going to go ahead and post this video because his way is actually pretty much exactly the same as mine. He just goes into more detail about how to do it with leading coefficients that aren't 1. So I taught you guys typically how to change like x squared plus 6x plus, I don't know, 4, 5, something like this. So I taught you guys how to change this into vertex form, but his video actually covers how to do something like that as well. Okay, so feel free to check out that video in the description in case you're having trouble with that. These I'm not going to be testing on. I'm only going to be testing on leading coefficient ones. But it doesn't really matter. The steps are the same because you're still just completing the square. But like I said, no big deal. I'll go ahead and link that video for if you're confused about how to change standard form into vertex form. You will need to be able to do that for your test. Okay? Now, as far as transformations go, let's talk about all these transformations real quickly. These transformations all start from this base form. F of x equals x squared equals x squared, or y equals x squared. And you've got your graph. And here is your base graph. It's just a basic parabola. Has that point at 1, 1, 1, or negative 1, 1, and 1, 1. So that's your basic x squared parabola. Remember that you have certain transformations. So we're going to go ahead and write these transformations, and each of them is actually going to have a graph associated with it. So I'm probably going to need more paper for this. We will see. I should have plenty of scratch paper to do this. I'll just write on the back of this. Okay. So let's go ahead and take a look at this. So our first kind of transformation, let's go ahead and talk about that A transformation. And for those of you that don't remember, if you have a negative A, so if A is less than 0, it's going to transform your graph in one way. So here is your base graph, okay? And I'm going to do all of your base graphs in blue for purposes of this. So this is f of x equals x squared. That's your base or parent function. Okay, we talked about that in class, parent function. Here's a different example. So this is f of x is equal to negative x squared. So you'll notice here that the difference between these two, this one was, I know that's really small, but that's x squared, and down here you've got negative x squared. The difference being that with x squared you have a positive 1 as your a, and with negative x squared you have a negative 1. So if a is less than 0, your graph flips upside down, flips. Upside down, I was going to stop at flips, but we'll go ahead and write it out. So it flips upside down. That's all that does if a is less than 0. Okay? Granted, that means if a is greater than 0, I guess I really should have done this in the opposite color. That's going to be confusing, but okay. And I'll go ahead and just write this so that you guys have it. If a is greater than 0, your graph is right side up, okay? You guys already used that because you're already used to this. Like x squared is just facing upwards. 5x squared is also facing upwards, right side up. All right? A is less than 0, a is greater than 0. Now, if a is a... Let's go ahead and do this in orange. If a is a proper fraction, okay. Remember, this could be positive, this could be negative, but if a is a proper fraction, then your graph gets skinnier. Or I'm sorry, it gets fatter. I'm so sorry. That was completely wrong on my part. So if A is a proper fraction, then your graph stretches horizontally or gets fatter. Stretches horizontally. So that's left and right. Remember, horizontal is left and right. Horizontally. Or gets fat. Okay? So if you don't want to think about it stretching horizontally, maybe you have trouble remembering the difference between vertical and horizontal, it gets fat. All right, so that's if A is a proper fraction. In class, I introduced that like this. So it looked like if A is greater than -1, less than 1, but A can't equal 0. Okay, so just in case that makes sense to you, that's great. That's how I wrote it in class, but I think that confused most people, so let's go ahead and go with this. If A is a proper fraction, then your graph stretches horizontally or gets fatter. Let's go ahead and draw an example of this. Remember, I told you I'm going to draw all my base graphs like this. So here's my x squared graph again. Alright, so that's... Alright, that one looked worse than the last ones, but that's okay. F of x equals x squared. And then let's say I do another graph. Again, I'm going to do this one downwards. That way they're just not... Well, I'll do this one upwards because I think that'll actually be a good example. Basically, you'll get another graph that looks like this. Just gets a little fatter. Okay? And this orange one's going to be f of x equals... I don't know, it's about twice. So that's about 1/2 x squared. The bigger this denominator is, the fatter your graph is going to be. So if this were like 1/100th x squared, then we'd have a super fat graph that definitely wouldn't fit on my paper. Okay, but and that was actually really small. It should be even bigger, but you get the idea. The point is that if you have a fraction here, remember it has to be a proper fraction, then you will get a fat graph. All right. Again, if this were a negative fraction, it would just be upside down and a fat graph. Cool. So that's horizontal changes. I'm sorry, that's horizontal dilation. Let's do vertical dilations as well. All right. So, oh, yes, I forgot. I would love to write this all on one page, but so we're actually gonna talk about what happens when they are not proper fractions. So we're gonna go with another stretching rule. Okay, so this is gonna be a vertical stretch or a vertical dilation. That means up and down. This next one. So if A is greater than 1 or A is less than -1. Alright, so if A is greater than 1, A is less than -1, I didn't really feel like using a union sign. But if it's one of these two, your graph stretches vertically. So your graph stretches vertically. Again, if you're confused by the math terminology, think of it as getting thinner. So the other one makes it get fat, this one gets thin. Okay, so this one loses weight. Here's my graph again. That's your parent function. Oh my gosh, I feel like they're getting worse, but that's okay. You guys are probably used to it by now. So there's that x squared graph, just like normal. And then here, again, we're going to use it, another positive. It's just going to be really, really stretchy and really skinny vertically. And I'm going to make this f of x, so this is my orange graph, f of x is equal to, I don't know, that's probably about 3 times. It's probably around 3x squared. Okay? And again, the bigger this number gets, so if this were a 100, it would just be like, it would look like a straight line. Like it would barely look like 2 lines because it would barely go straight up the middle. If this were just a 2x, it would probably be a little fatter. So if it were 2x squared, let's go ahead and add another graph onto this for kicks. If it were like 2x squared, it won't be quite as narrow. It'll just be a little bigger. Something kind of like that. These are all estimations, but you get the idea. Okay, so that's the difference between how you stretch horizontally, stretch vertically. So if you have a proper fraction, that was on this page. All right, so if you have a proper fraction, your graph is going to get fatter. If you have an improper fraction, or if you have any number bigger than 1 or less than -1, you're just going to stretch more upwards. Okay? We talked about the logic in class. I'm not actually going to talk about the logic here. I'm just going to go ahead and make this video from memory. That way you guys can be prepped for the test. Let's see. Oh, let's talk about the actual shifts now. So we've talked about dilations, we've talked about flipping up and down. Let's talk about the actual shifts. So down here, we're going to talk about horizontal shifts first. So this is going to be moving left and right. So if you have a change in h, if you change h, remember there's h in that vertex form of our parabola. So if you change h, you shift left or right. And this is actually going to be the opposite of what you might think. Okay, so this is shifting left or right. And it's going to be the opposite of what you'd be used to. I'm going to go ahead and highlight this in orange just so that you have it. The idea is that a negative h is rightward movement. And that's going to be the opposite of what most people think, because obviously the positive side of the graph is over here. But remember, in your vertex form, you've got that x minus h squared. So you're going to be doing that opposite form of that h. All right, so it's going to do the opposite. That says rightward. Well, that's okay. So if you have a negative h, it's rightward. And then if you have a positive h, it's going to be the opposite, which is left. Okay, leftward. Cool, so let's go ahead and graph this on a graph. Again, let's do our parent function. That was a little better, actually. Okay, so that's our basic x squared function. F of x equals x squared. Okay, and what's going to happen is we're going to do a new graph now, and we're just going to shift it over to the right, because I wrote this on the left, so I just want it to be look a little prettier. We're going to shift it right, I don't know, let's say 3 spots, just because it'll stand out. 1, 2, 3. Okay, so what's going to happen is you're going to put your base of your graph, and it's going to go up again, something like this. And all this orange graph is f of x is equal to, and instead of x squared, it's going to have an h value now. And remember, if we do a rightward, it's going to have a negative h value. Since we shifted over 3, it must have a negative 3 in the h spot. So this would be x minus 3 squared. Okay, this is x minus 3 squared. Again, it's a negative h, so we shifted to the right however many h's. This was 3 h's, so we move 1, 2, 3 h's over. Okay, so that's how you shift rightward. If this were a positive 3, then we would have put another graph. In fact, we can actually kind of do that. 2, 3. That was really not to scale, but this would be f of x is equal to x plus 3 squared. And so again, that would go 1 spot, 2 spot, 3 spots over, not to scale, and be the same exact graph upwards. Okay? So that's how to shift left and right. Negative h's are right, positive h's are left. Cool. Let's go ahead and move on. I will need more sheets of paper, actually. Where'd my... Oh. Okay. So we did... Alright, awesome. Let's go ahead and switch over to our vertical shifts. Okay, so our vertical shifts are going to follow the same kind of rule, except it's if you change the very last letter that we've dealt with. So we dealt with A, we dealt with H, there's one more letter in vertex form that showed up. So if K changes, we shift vertically. Okay, we shift vertically or up or down. Up or down. Shift up and down. Okay, this just shifts up or down if K changes. You can think of K similarly to your C in standard form. I know a lot of you guys were saying that during class, but one thing I don't want you to mix up is that K is not necessarily your y-intercept. Okay, K is not necessarily your y-intercept. Alright, let's see. So, I'll go ahead and highlight these in different colors again. This one is going to be exactly what you'd think. So a positive K would be shifting up. I'm not going to write upward. Well, upward. I guess we'll keep it consistent. Positive K is upwards. A negative K is downwards. Okay, Positive k is upwards, negative k is downwards. And we're going to go ahead and graph this. Let's go ahead and get our basic x squared graph. Here's our parent function, f of x equals x squared. And let's go ahead and shift it. I'm going to do a couple of shifts on this one just so that it looks a little bit nicer. Yeah, so that it looks a little nicer. What we're going to do is we're going to shift downwards, but I'm also going to flip the graph. So we're going to do these at the same time. All right. So this would be an example like f of x is equal to, and we're going to change our a to make it flip downwards. Remember, you just need a negative to flip it downwards. So I'm going to put a -1 as my a, my x. Remember, I don't have an h in this one because I'm not shifting left or right. But I do have an x that I'm going to keep squared. I could have written this as -1x squared, but I wanted to imply that h is 0 for sure. And let's go ahead and make k, I don't know, we'll shift it down just 2 spots. All right, we won't shift it down far. So first off, let's do our downward shift, 2 spots, so we know here's our base. Okay, that's our vertex spot. And then we're going to make it go downwards because we have that -a. Looks like that. Okay. Easy, easy. That's all it is. So it's a downwards or upward shift. Again, this is all based off of your vertex. If you actually wanted to find other points on this graph, we'd have to make an XY table. So you would test like 1 and you would get that this is, let's see, if we tested 1, you would get -3. Okay, so this would be 1 comma -3. Again, you would just plug this into an XY table to figure that out. All right, so those are your upward shifts, downward shifts, leftward shifts, rightward shifts, and then dilations. I'm pretty sure I bit my words on a lot of those, but you guys should be good. That covers all of our different shifts. I'm gonna hook the transformation video into the link in the description, and that should cover all of your material for this chapter. So I think you guys are good. Let me go ahead and show each of these pages one by one. So again, let me get it all on one screen. There is your vertex form, and then your parent function of x squared. So vertex form, parent function. Remember your a, your h, and your k all have values. In fact, I'll put all these on another page in just a second after I show you guys each of these pages. Okay, so then there were these dilations. Oh, actually this was the next page. There you go. So then there were these. So remember your positive a is going to be upwards, your negative a is going to be downwards. Probably should have done this in orange as well, so that was my mistake. But if a is negative, it's downwards. Remember, that's old material. We've covered that, I don't know, like a month ago. If a is a proper fraction, it's going to get fatter. That's that orange one, so it's going to get fatter. The smaller your fraction, so 1 over 10, 1 over 20, 1 over 100, the smaller and smaller you get, the fatter and fatter your graph gets. Okay? Over here, there we go. So if a is greater than 1 or if a is less than -1, you're going to get a thinner graph. It just depends on whether or not it points up or down. So it gets thinner and thinner the bigger your a gets. So a got 3, it was at 2, so at 2 it's kind of skinny, at 3 it's super skinny, at 100 it'd be like ridiculously skinny. Same goes for the negative version. So at -2 it'd be kind of skinny, -3 it'd be pretty skinny, and then -100 it'd be super skinny, like one line. Okay, down here if you change h, you're going to shift left or right. So go ahead and pause there, and then the last one is if you shift your k, or I'm sorry, if you change your k, you'll shift vertically. I know I was all over the place on this video, but I just wanted to get it out as early as possible in the morning, that way you guys would have it for your test. You should be good. Oh, I will do one more video on how to find the x-intercepts and to properly graph a vertex form one. I just don't want to make this video too long. So I'm going to go ahead and stop this video, and I'll record another one right this second. All right, guys, best of luck.